You use Git every single day, right? And it's great. Until it's not. And then that cold panic sets in. Well, today we're going to change that. We're going to build a mental model from the ground up that will finally make Git feel intuitive and hopefully take away that fear for good.
Oh man, we have all been there. You're staring at a completely broken repository, it's late at night, and you're just frantically pasting commands you don't really understand, hoping, praying you don't make things even worse. It's like a rite of passage for developers, but it really doesn't have to be this way.
So what's the real problem here? I think it's that most of us, even folks with years of experience, we just memorize a list of Git commands. We never really get a feel for what's actually happening underneath the hood. We're missing that core mental model, and that's exactly what we're going to build, right now. All right, first things first, I want you to forget everything you think you know about Git. Just for a minute. We're wiping the slate clean and going back to the very beginning, to the single fundamental building block of the entire system. And here it is. This is the most crucial concept. A commit is a snapshot. Think of it like a complete photograph of every single file in your project at one specific moment. Now, here's the part that trips everyone up. It is not just a list of the changes you made. It's the whole picture, the entire state of your project, frozen in time.
And if you were to crack open one of these commits, what would you find inside? Well, it's actually pretty simple. You'd find just three things. A pointer to that photograph of your code, a little bit of metadata, who made the commit, when they did it, and why, and this is the important one, a pointer to the commit that came directly before it, its parent.
Okay, so we've got these individual snapshots, these commits, but how do they all link together to tell the story of our project's history? Well, this is where we zoom out and see the real magic of Git. Remember that parent pointer we just talked about? That's the key. Every single commit points backwards to the one before it, which points to the one before that, creating this unbreakable chain that goes all the way back to the very first commit you ever made. A new commit knows who its parent is, but the parent has no idea about any future children. The arrow of time in Git only ever points to the past. Now, this structure has a kind of scary-sounding technical name, a directed acyclic graph, or a DAG. But please, don't let that name intimidate you. All it means is, it's like a family tree. Directed just means the arrows only point one way, from the child to the parent. And acyclic just means you can't have any weird time loops. You can't be your own grandparent. It's really just a family tree for your code. That's it. So, we have this giant, sprawling family tree of our project's history. So how do we move around in it? How does Git even know where we are? The answer is branches. And I promise you, they are so much simpler than you probably think. This right here, this is one of the biggest aha moments you can have with Git. Most of us think of a branch as this big, heavy, separate copy of our entire project. But it's not. It's actually just a tiny little pointer. It's basically a sticky note with a name, like feature branch, that you stick onto one specific commit. That is all it is. And that's why creating and switching branches in Git is literally instantaneous. Okay, so if branches are just sticky notes, what's head? Well, head is basically the "you are here" arrow on the mall map. It's just another pointer, but its job is to point to the branch you're currently on. So when you type git checkout main, all you're doing is moving that head arrow to point at the main sticky note. Simple as that. All right, now that we have this new model in our heads, commits or snapshots, branches or pointers, we can finally tackle the commands that cause the most stress. This new understanding is the key to mastering the tools for moving through and sometimes even changing our project's history. But wait, one last crucial idea. You gotta know that Git really has three main areas. First, there's your working directory. That's just the files you can see on your computer. Then there's the staging area, which is like a waiting room or an on-deck circle for the next snapshot. And finally, you have the repository itself, the permanent, unchangeable history of commits. Knowing these three zones is essential to understanding what the undo tools actually do. First up is Git Checkout. I want you to think of this as your completely safe read-only tool. Its main job is to move your head pointer around. You're basically just time traveling, looking at different snapshots in the museum of your project. It'll update your working files to match whatever commit you're looking at, but it never ever changes the history itself. It's totally safe. Next, let's talk about the powerful and sometimes scary Git Reset. Its main job is to move the branch pointer, that sticky note, to a different commit, but it has three modes. A soft reset just moves the pointer. That's it. A mixed reset, which is the default, moves the pointer and it empties out your staging area.
And then there's hard. A hard reset moves the pointer, empties the staging area, and overwrites the files in your working directory. This is the one you have to be careful with because it can wipe out work you haven't committed yet. So what happens if you need to undo something that you've already shared with your team? You can't just use reset because that rewrites history, and that's a big no-no for shared branches. That's what git revert is for. It's the polite way to undo. It doesn't delete anything. Instead, it creates a brand new commit that contains the exact opposite of an old one. So history is added to, not rewritten. It's the safe way to undo in public. And finally, the infamous rebase. The whole point of a rebase is to make your project history look cleaner and more linear. So instead of having a messy merge commit, the idea is that you take all the commits you made on your feature branch and you replay them one by one right on top of the latest version of the main branch. But here is the secret to rebase, the thing you have to understand. It doesn't actually move your old commits. It can't. Commits are permanent. Instead, what it does is create brand new copies of each of your commits with new parents. The old commits are just left behind, abandoned. And this is why you must never, ever, ever rebase a branch that other people are also working on. You're not moving history, you're rewriting it. So, to just quickly recap how safe these tools are. Checkout and revert, super safe. They don't rewrite history. Reset, kind of medium risk. It's fantastic for your local work, just be mindful. And rebase on a shared branch, that's low safety. It's an amazing tool for cleaning up your own commits before you share them, but it can be dangerous afterwards.
Okay, after all that talk about danger and rewriting history, I want to share with you the single most reassuring, most comforting concept in all of Git. This is the part that lets you sleep at night.
Even when you think you have made a catastrophic, career-ending mistake, I want you to remember this. Git is fundamentally designed to prevent data loss. It almost never actually deletes a commit right away. All it does is remove the pointers. It just hides it, making it harder to find. But it's still there. So, how do you find these lost commits? You use your secret weapon, the reflog. Think of the reflog as your personal diary. Git keeps a private log of every single place your head pointer has been for about the last 90 days. So if you accidentally do a reset-hard and think you've lost hours of work, don't panic. The reflog will have the ID of the commit you were on right before the disaster. You can find it, and you can get it back. It is your ultimate safety net.
So let's put it all together. This is your new mental model. Git is just a database of snapshots. Its history is a graph, like a family tree. Branches and head are nothing more than lightweight pointers that help you navigate that graph. All those scary undo tools are just different ways to move those pointers around. And if you ever get lost, you have an amazing safety net called the reflog.
With this model, you can stop memorizing commands and start understanding the system. So the next time something goes wrong in Git, and it will, I want you to stop and take a breath. Don't ask yourself, what's the magic command I need to copy from Stack Overflow? Instead, ask yourself, okay, where are the pointers now and where do I need them to go? Trust me, that little shift in perspective will make all the difference.